You will explain the last chapter of this course, chapter 8, angle modulation reception. And the objectives of this chapter is to study the process of FM demodulation, to study the operation of tuned circuit FM demodulators, and lastly, to understand the purpose of using amplitude limiters. So, as a recap, we have learned about AM receivers in chapter 5. Then it's quite easy for you to understand on this double conversion FM receiver. It is almost similar to AM receiver. As we learned earlier, the receiver must have 5 stages. RF stage, the mixer or converter stage, the IF stage, then detector stage, and lastly audio stage. So in this double conversion FM receiver, if we see here, it also has the RF stage, the IF stage, and then the mixer or converter, the detector stage, and also the audio stage. All right, but a little bit different in this FM receiver. It uses two mixers and two local oscillators uh, instead of only one mixer and one local oscillator for AM receiver. Okay, another one more difference between FM and AM receivers. In FM receiver, it use a limiter to saturate the IF gain during the conversion from RF to IF stage. Okay, so the rest of the components are almost similar with the one that uses in AM receiver. So in the FM demodulator or FM receiver, we use what we call tune circuit frequency discriminator to convert the FM signal to AM signal, so that the demodulator inside a receiver will demodulate the AM envelope using peak detectors. So I think about tune circuit, we already learned about this in chapter 3 under oscillators. And by now, you already know about tune circuit, what is tank circuit, and sort of. And if you don't remember, please go back to the chapter 3 and do some revision yourself. So for the tune circuit frequency discriminator, it has 4 type of detectors that mainly used for FM receiver. First is slope detector, and then balance slope detector, ratio detector, and lastly Foster-Seeley discriminator, or what we call as phase shift discriminator. But in this slide or this video, I only explain about this for the first 3 detectors only. So for the slope detector, okay, for the slope detector, this is the schematic diagram of single-ended slope detector, which is the simplest form of tune circuit frequency discriminator. And this detector uses one diode, one coil, 2 capacitors with different type, and also one resistor. So this will be the easiest slope detector that we can use when designing our FM receiver. And this is the the voltage versus frequency curve, where we can find the frequency of the tank circuit when we get the maximum output voltage on the curve. So it also shows us about if the IF frequency is more than frequency of carrier, the output voltage will increase, and when the IF frequency less than carrier frequency, the output voltage will decrease. So this is what meant by the frequency deviation over here. For the balanced slope detector, it uses the slope detector that we have learned earlier, but this time it's actually double-ended or two-ended slope detectors. So the first, the first slope detector is over here, another one is over here. And then if you see over here, it has 2 parts. That the first part is actually the first inversion. It will perform the FM to AM conversion, and the second part, it will remove the information signal from the AM envelope. So if we see the curve over here, the LA and CA over here can be tuned to get the IF center frequency, all right, and to be above the IF center frequency. Sorry. So for the LB and CB, it can be tuned to get the frequency that is below the IF center frequency. Right. The next is the ratio detector. The operation of ratio detector and also Foster sealer is similar, but the only difference is actually in ratio detector, the diode D2 here is put reverse compared to D1. But for Foster sealer, both diodes is put in the same direction to the output. Okay, so the advantage of using ratio detector is this detector is immune to amplitude variation, all right, and it's very good to use when we want to make the frequency more than output frequency, okay, or oscillation frequency. Okay, next is the PLL FM Modulator. So this is actually a part or component that you can use in designing your FM receiver. You may have the PLL FM demodulator, which is actually one simple IC with model number XR2212 PLL. So having this PLL demodulator, FM demodulator is actually the simplest and easiest way to design our receiver, and then it requires no tune circuits. So the phase comparator will produce that taken by phase detector over here will produce correction voltage and feedback to the input VCO. So VCO here will track frequency changes in input signal over here and then lock that frequency so that the correction can be made by the phase corrector. So the concept or operation of PLL I already explained in chapter 3 as well. So you may go back to that chapter in case that you have forgotten how the PLL works. Another one type of the modulator is what we call quadrature FM demodulator. So this actually will extract the original information signal from composite IF waveform by actually multiplies two signals that actually has quadrature signal or 90-degree out of phase inside a product detector over here. So in this FM demodulator, it only has three things: phase shifter over here, and then the tank circuit, and also product detector. Then we can demodulate the received FM signal inside our receiver. Okay, so next is about limiter. So as I mentioned earlier, the limiter is actually, we can find it in FM receiver, not in AM. So what this limiter does is to remove the unwanted amplitude variation that may become interference to our signal, to our system. Okay, so this will be the schematic diagram of a limiter where which you use one transistor over here and connect to the IF input signal and then output FM demodulated signal. All right, also explained to you in chapter 2 about band limiting effect. So the band limiting effect actually what have we use here in limiter actually. So by using band limiting, the limiter will try to remove the harmonics and also the intermodulation distortion that presents in rectangular pulses due to hard limiting. So from before filtering, the signal might become the rectangular pulses, and then when after filtering, the signal can be changed to be sine wave or cosine wave, and then this area basically we want to remove that may contain harmonics or intermodulation distortion and become noise to our system. So Another example of FM receiver that you may consider in designing your own receiver, FM receiver, is to use single IC, Signitex TDA 7000 IC FM radio, which actually in this one IC, 18 pins, we can have all components of receivers inside one IC, where this is the RF input, this is the mixer, alright, this is the IF filter, IF limiter, local oscillator, demodulator, all right, and also what else? And this will be the output of the signal. Right, so it's very convenient. The easiest way to design our FM receiver so that we can demodulate the received FM signal and try to extract what is the information contained in that received signal. This will be the data sheet of Signetic TDA 7000 IC FM radio. I will try to share with you in column if I found this document in my possession. Okay, so other FM system that you may use or consider to use is actually using NESA 614A IC. It's actually low power and IC FM IF system and widely used in FM cellular radio, high performance FM receivers, IF amplification and detection up to 25 megahertz, spectral analyzer, data transceivers, and lots more. Another one, if you want to design a low voltage but using high performance mixer, you can use NESA 616 that actually most used in the portable FM cellular radio, cordless phone, wireless communication systems, VHF receivers, and lots more. Okay, so by this slide, basically, I have and you have completed all chapters in this course, and I want to congratulate you to finish this course and study by yourself. So I hope that you can understand and try to what call it go to do this assessment that I have prepared for you in Kalam. So I think that's it. Thank you for joining and listening to my videos and have a good day, everyone. Thank you.